Hi guys, welcome to my YouTube channel Prepare with Arun. This video is all about how to resolve a given force and how to find the resultant of a given force system. Meanwhile, if you haven't subscribed to my channel, please do subscribe and keep supporting me. Thank you. First we will see how to resolve a given force. So if your force is purely a horizontal force or if it's completely vertical force, then there is no need to resolve the given force. But if your force is inclined at some angle like this, so here the given force F is inclined at an angle of 60 degree with x-axis. In this case you have to resolve the force. How to resolve this? So I am going to resolve it along x-axis and along y-axis. So first we will draw the force. So it is along x-axis and one will be along y-axis. Now what will be the direction of the force? Since the given force is moving away from the origin, these two components will also move away from the origin. So this is the direction of the force. How to determine the magnitude? So whichever component is nearer to the angle. So this component is nearer to the angle. So this will be F cos 60. If it's nearer to the angle, it will be cos. This is away from the angle, so this will be F sin 60. In other words, here the force F is making an angle 60 degree with respect to x-axis. So the x component will be F cos 60, whereas the y component will be F sin 60. In this case, the force F is making an angle 60 degree with y-axis. Therefore, the y component will be F cos 60 and the x component will be F sin 60. Okay. So depending upon whether the force is making an angle with respect to y-axis or x-axis, the magnitude of this x and y components will vary. There is another approach to solve the same sum. So here the force is making an angle of 60 degree with y-axis, therefore you can find this angle. So if this is 60, we know that the complete angle is 90 degree, therefore this angle will be 30 degree. Now we know the force is making an angle of 30 degree with x-axis. Now you can say that this is F cos 30 and along y it is F sin 30. Now we will try to resolve these forces. So here the force is moving away from the origin, therefore the components will also move away from the origin. Always remember, the given force should always be between its horizontal and vertical components. Okay, you should not draw like this. The given force should be between the horizontal and vertical component, and since the force F is moving away, the components are also moving away. And here you have theta, so this component will be F cos theta and this component will be F sin theta. In this case, here also it's moving away, so the components will be like this. Okay, so since this is theta, this will be, if this is F, then this will be F cos theta and this should be F sin theta. Now for this, here also it's moving away, so the components will be like this. So this is F cos theta because theta is nearer to this, and this is F sin theta. Okay. So in this case, the force is towards the origin, so the components will also be towards the origin. So this will be the direction of the components. Direction changes here. Since the given force is towards the origin, the components are also towards the origin. So this is F cos theta and this is F sin theta. But this is same as this force. You can see the direction. So this force is like this. Okay. Only the angle differs. Here angle theta is with respect to y axis, whereas here it's with respect to x axis. That is the only difference, whereas the direction remains the same. So before knowing the resultant, we will first understand the sign convention. This is what you will be applying in all the sums. Okay. So if a force is acting from left towards right, if it's acting towards right, we consider that as positive. If it's acting towards left, we consider the force as negative. Towards right positive, towards left it is negative. Similarly, for vertical forces, upward force is considered as positive, downward force is considered as negative. Okay. Next we will see how to find resultant of a given force system. So the first step is to resolve the given force into its horizontal and vertical components. So how many number of forces are there? For all the forces you have to resolve them into their horizontal and vertical components. Next you have to find the algebraic sum of all the horizontal components and let that be sigma fx. So what is this algebraic sum? That means you have to take the sign convention into account. So if it's positive you have to add, if it's negative you have to subtract it. Next you have to find the algebraic sum of all the vertical components and let that be sigma fy. Then the resultant r is given by root of sigma fx square plus sigma fy square. And the direction alpha is given by tan inverse of sigma fy by sigma fx, where alpha is nothing but the angle made by the resultant with x-axis. Three coplanar concurrent forces are acting at a point as shown in the figure. Determine the resultant in magnitude and direction. So you have three forces, one 8 Newton force, one 5 Newton force and other one 3√3 Newton force. So the first step is to resolve all the given forces. So here the 5 Newton force is a completely vertical force, so there is no need to resolve it. This is also a complete horizontal force, so there is no need to resolve this also. Only this 8 Newton force is inclined at an angle of 30 degree with x-axis, so we will resolve this. Since it's away from the point, the components will also be away from the point, so this will be 8 cos 30. 8 cos 30. So that's nothing but 8 into √3 by 2, so that is 4√3. So this component is 4√3 Newton. This is 8 sin 30. Sin 30 is 1 by 2. So 8 into 1 by 2 is 4 Newton. So the first step is over, that is resolving the given force system. Next is we have to find the algebraic sum of all the horizontal components. So here you have two horizontal components. One is this 4√3 Newton, the other one is 3√3 Newton. So as per the sign convention, this is positive direction and this is negative. So sigma fx is given by 4√3 Newton minus 3√3 Newton. So that's nothing but √3 Newton. The next step is to find the sum of all vertical components, that is sigma fy. So here you have two vertical components, 4 Newton force and 5 Newton force. So upward force is positive, downward force is negative. So it is 4 minus 5. So that is minus 1 Newton. Now the formula for resultant is r is equal to root of sigma fx square plus sigma fy square. So that is √3 the whole square plus minus 1 the whole square. So that is 3 plus 1 √4. So the resultant is nothing but 2 Newton. So we have found the magnitude of the resultant. Next, direction is given by alpha is equal to tan inverse of sigma fy by sigma fx. So that is tan inverse of minus 1 by √3. So this is the direction of the resultant, where alpha is the angle made by the resultant with respect to the positive x-axis. Find the resultant of given system of forces. So in this sum we have three forces, one 7 kN force, 2√3 kN force and a 10 kN force. So here the 7 kN force is a complete horizontal force, so no need to resolve this. This is also a vertical force, so no need to resolve this. Only this 10 kN force we have to resolve. But in order to resolve this, we don't know this angle. Only if you know this angle, I will be able to resolve. So instead of angle, what they have given is the slope of this force. So from the slope we can find the angle. How? So we know that slope is nothing but tan theta. In terms of theta, slope is tan theta, and from this how to find the slope? It's nothing but y component by x component. So y is root 3, x is 1, so it is root 3 by 1. So that's nothing but root 3. So when tan theta will be root 3? When theta is equal to 60, tan 60 is nothing but root 3. So theta is 60 degree. Find the resultant of given system of forces. So in this sum we have 3 forces, on 7 kilonewton force, 2 root 3 kilonewton force and a 10 kilonewton force. So here the 7 kilonewton force is a complete horizontal force, so no need to resolve this. This is also a vertical force, so no need to resolve this. Only this 10 kilonewton force we have to resolve. But in order to resolve this, we don't know this angle. Only if you know this angle, I will be able to resolve. So instead of angle, what they have given is the slope of this force. So from the slope, we can find the angle. How? So we know that slope is nothing but tan theta. In terms of theta, slope is tan theta, and from this how to find the slope? It's nothing but y component by x component. So y is root 3, x is 1, so it is root 3 by 1. So that's nothing but root 3. So when tan theta will be root 3? When theta is equal to 60, tan 60 is nothing but root 3. So theta is 60 degree. So once you know the theta, you can easily resolve this. This is nothing but 10 cos theta, that is 10 cos 60. Cos 60 is 1 by 2, so 10 into 1 by 2 is 5. So this is 5 kilonewton. And the vertical component will be 10 sin 60, that is 10 into root 3 by 2, that is 5 root 3. Okay. So we have resolved this. Next we have to find sum of all horizontal component. So here this is positive and this is negative. So it is 7 minus 5, that is 2 kilonewton. Sum of all vertical forces is upward is positive, downward is negative. So it is 5 root 3 minus 2 root 3. So that's nothing but 3 root 3 kilonewton. Now we will find the resultant using the formula R is equal to sigma fx the whole square plus sigma fy the whole square. So that is 2 square plus 3 root 3 the whole square. So 2 square is 4 plus 3 square is 9, root 3 the whole square is 3. So 9 into 3 it is 27. So that is root 31 kilonewton. So resultant is root 31 kilonewton. 3 forces acting on a body are shown in the figure. To have the resultant force only along the y direction, the magnitude of the minimal additional force needed is. Okay, fine. So this is the given force system. So before starting this sum, we will just understand what is meant by sigma fx and sigma fy. In the previous sums, we have found out sigma fx and sigma fy, right? That is nothing but if you resolve the resultant into its horizontal component and vertical component, I'll be getting sigma fx and sigma fy. That is, sigma fx is the horizontal component of the resultant force, sigma fy is the vertical component of the resultant force. So here it's given that the resultant should be along the y direction. That is, the resultant is a completely vertical force. That means the horizontal component of the resultant should be equal to 0. That is, sigma fx should be equal to 0. So in this sum we have 3 forces. So first we will resolve all these forces and then we will find the algebraic sum of the horizontal component. Now for this 1 Newton, what is the horizontal component? It will be 1 cos 60. And it will be acting along this direction, so it is positive. Next for this 4, it will be 4 sin 30 because 30 is made with respect to y axis. So it will be 4 sin 30 and the direction will be towards left. So it will be minus. So minus 4 sin 30. If this angle is 30, then this angle should also be equal to 30 because vertically opposite angles are equal. So for this 2 Newton force, the horizontal component will be 2 sin 30 and the direction is towards right, so positive. So 2 sine 30. Now 1 cos 60, cos 60 value is 1 by 2, so 1 into 1 by 2 is 0.5, minus sine 30 is 1 by 2, so 4 into 1 by 2 is 2, plus 2 into 1 by 2 is 1. So it's 1.5 minus 2, that is nothing but minus 0.5 Newton. So minus 0.5 Newton, that means that the force is acting towards left side. Minus indicates that it is acting towards left side. Now in order to make this force 0, I should add an additional force of 0.5 Newton towards right. Then only both the force will be compensated. So now sigma Fx is acting like this. It is 0.5 Newton towards left. Now to make this as 0, I should add an additional force of 0.5 Newton, same magnitude, but in the opposite direction. Then only the resultant will be 0. So the additional force that has to be added is 0.5 Newton. Option C.